Hello, this is Emily Pham presenting Lab Report 1 for Physics 2211. The purpose of this lab is to observe and model an object moving at a constant velocity. Velocity is a vector quantity which indicates the speed and direction at which an object is moving. While changes in velocity indicate an interaction with the object's environment, this lab focuses on when the object observed is moving at a constant velocity. An object moving at constant velocity is expected to travel a certain distance within the same time frame repeatedly. The average velocity equation is denoted as the first equation on the right. The main physics principles applied in this lab are Newton's first and second law. Newton's first law, known as momentum, is defined as the product of mass and velocity and is denoted by the second equation on the right. Newton's second law is the momentum principle, which states that the change in momentum is an object is equal to the net interactions or forces enacted upon the object over a set span of time, as denoted by the third equation on the right. In addition to the analysis of a video using Tracker, a computational model created with GlowScript will use these mentioned principles to predict the motion displayed in the video. This graph models the comparison between the predicted position calculated by the analytical model on GlowScript and the observed position noted on by Tracker of the experiment. For the experimental part of this lab, I recorded a video of a chapstick tube rolling after I initially gave it a push. I then uploaded this video to the Tracker and calibrated the axes as shown. I also proceeded to calibrate the scale of the video by defining the length of the chapstick video as well as proceeding to track the position of the chapstick tube as a function of time by noting down its position during every frame of the video clip I used with the tracking tool. These positions were then graphed down by Tracker and the previous model shown. For the GlowScript code, the initial conditions are predicted with the object moving at a constant velocity. I defined this system as the chapstick tube and its surroundings as the table and the earth. I measured the mass and I set the initial time and position as the same initial time and position as the video clip of the experiment. I also used the first two data points as well as average velocity equation to determine the initial velocity of the system. For the calculation loop, in order to predict the position of the system, Newton's second law can be applied by rearranging it by further substituting the momentum with Newton's first law. I can iteratively calculate the velocity of the system at a certain time with the experiment by adding the change in velocity to the starting velocity using the following equation. The force of gravity enacted upon the system is assumed to be equal to the normal force enacted upon this system by the table, resulting in a net force of 0. The position can then be found iteratively as well by creating an equation for the new position using the range form of the average velocity formula so that the change in position is by itself. The new position would be found by adding the change in position to the starting position using the following equation. Since the time was already defined to be 100th of a second, the average velocity in units of meters per 1 second has to be divided by 100 to fit this new time step. Overall, the predicted positions of the system modeled by the code are very similar to the observed positions of the experiment. However, the observed positions start to deviate slightly as time passes, the system seeming to slow down and travel shorter distances. This difference could be due to an error in the experiment, such as not accounting for possible friction or drag, which exert additional forces upon the system, meaning that net force and thus change in momentum could be non-zero vectors. What if the axes were flipped using Tracker? All the quantitative values and aka magnitudes would remain the same aside from having a change in direction in the negative direction instead of the positive direction denoted in the previous slides. What does it mean to have a net force of 0? In this particular experiment, there are two accountable forces which sum up to create a new force of 0. Net force, of 0, gravitational force exerted upon the system by the Earth, and normal force exerted by the table upon the system. The gravitational force acting is in the negative y direction, and the normal force exerted by the table onto the system is in the positive y direction in response, keeping the object in place, since the object would otherwise remain at rest if it were to start at rest under these same forces. It can be assumed that these forces are equal and opposite to each other, resulting again in a net force of 0.